Welcome everyone. So today in this lecture we will discuss normalization and its types in our DBMS. So starting with the definition part of the normalization, what is normalization and why it is required to perform on our existing database. So normalization can be defined as the process of organizing the data in the database to avoid data redundancy, and there are several types of anomalies that needs to be avoided. So if our database is inconsistent, then there may be arise several kinds of problems like insertion anomaly, update anomaly, and deletion anomaly. Okay, so if our database having several copies of the similar data, then it may be cause several problems like insertion anomaly. If we discuss about the insertion anomaly, what is insertion anomaly? If we can say, for example, if we trying to insert and record in our database, but because absence of some field, that record is unable to get inserted. For example, if we discuss an example of employee relation, if there is some fields like employee ID, employee name, employee address, department. For example, if a new employee, that is not employee but a trainee, comes to the organization, then if you want to insert the record for that trainee, because the trainee having no department and department cannot accept any, the relation cannot accept any record having null value for the department, so it will cause a problem that is termed as insertion anomaly. Similarly, what is update anomaly? For example, if in our database there are several copies of, for example, taking the example of employee itself. So if there are some field like contact number or employee address, if an employee wants to update his contact number, because at a point, if there is several copies, if you want to update his contact number, it will get updated for a particular set of data, but in other copies of the similar data it will not get updated, so it will cause a problem in future while using the data for the employee. Similarly, if in case, if for example we want to delete some data, okay, so if we deleted some data, but along with the deleted data it also deletes some important information, so it may cause a problem for handling the database. For example, if there is a department having some employees and that particular department needs to be deleted because this is merged with some other department, or it may be dissolved, then in case if that department gets deleted, so all the employees within that department, the data that was related to those employees will get deleted from the relation. So there are several kinds of problem that needs to be handled. So what is the solution? Solution is to normalize the database. So what is the normalization process? The process of organizing data into table such a way that the result of using the database are always ambiguous and intended. Okay, such normalization is intrinsic to the relation database theory. So it may affect the duplicating data with the database and often results in creation of additional tables. So while performing the normalization, it will results in creation of additional relations, or we can say additional tables. So what are the types of normalization? We can say there are several types of normalization, like first normal form, second normal form, third normal form, and the extension of third normal form, it is termed as bias-scored normal form, and the fourth normal form and the fifth normal form. Okay, so there are 6 normal forms where the BCNF is an extension of third normal form. So starting from the first normal form, what is the first normal form? So a database is said to be in first normal form if it falls under these conditions. What are those conditions? The attributes must be single valued. If any attribute having more than one value, if it is not atomic in nature, then it will be not in first normal form. The domain of attribute must not change. For example, if there is a field that holds the date of birth of an employee, it cannot include add in this column, we cannot add name of the employee. So it must having the same domain values. Okay, so the fields containing date of birth should not contain the name of the employee, for an example. So, and every column or attribute must have a unique name. Okay, so it is clear to understand. So every attribute and every column must have a unique name. It should not be repeated or similar. Okay, and the order of doesn't matter. Okay, the order of data doesn't matter in our relation. It may be okay. So in our relation, the order of data doesn't matter whether it is in first row or in second row and third row. Whatever our record is existing in our database, if it is organized properly, it will fetch with the query processing. So we can take this example for understanding of the first normal form. Here we see this is a table as product having the fields product ID, color of the product and its price. So we can see for the product ID 1, we have more than one value for the field for the column color. Okay, this product having two colors, it may be either black or red, having its price 210. Similarly, the product ID 4 having green and blue product, okay, having color green and blue. Okay, so we can see that this table is not in first normal form because it's having multiple values for the attribute color. So if we want to perform the normalization and to make this relation into first normal form, what we will do, we will break this into two relations for product ID and price and product ID and color. So we can say that the combination of product ID and price will make unique for each and every record. Similarly, for product ID and color will be make unique for each and every record in this relation. So the primary key identification is also done here for both the tables, and we can see there is no repetition of its primary keys. Okay, for here it is product ID and color, and here we can also make the product ID as a primary key because there is no repetition for any. Okay, what is the second normal form? So the first condition that needs to be in case of verifying whether a given relation is in 2NF, the first of all it should be in first normal form. Okay, the first condition is it should be in first normal form. Then we will identify that no non-prime attribute is dependent on the proper subset of any key of table, of any candidate key of table. So what is the meaning of non-prime attribute? What is non-prime attribute? So non-prime attribute is what? Which is not the part of any candidate key. For example, if there are three attributes A, B, C, okay, if A and B is part of candidate key, then we can say A is prime attribute. Similarly, we can say B is also prime attribute. Okay, but C non-prime. Okay, why non-prime? Because it is not the part of candidate key. Okay, so what is the condition that needs to met when verifying whether a relation is in 2NF or not? So there is this condition needs to verify that no prime attribute is dependent on the proper subset of any candidate key of table. So let us take an example. For example, in this relation, this is a purchase detail relation having the fields customer ID, store ID and location. Here we can see that the customer ID having one value with the store ID one value is located at Patna. Similarly, this customer ID 1 visits store ID 3 which is located at Noida. Okay, so we can see in this table has composite primary key. What is the primary key for this relation? Customer ID and store ID. Okay, so combination of this makes the primary key, or the we can say the key for this given relation. Okay, and here also we can see this particular location is dependent on where? Store ID. Okay, if the store ID is 1, then it is located at Patna. If the store ID is 2, then it is located at Delhi. If the store ID is 3, then it is located at Noida. So this means location is dependent on store ID. Okay, and the store ID is part of what? Primary key. So we having customer ID along with store ID is our candidate key or primary key. But this relation is this functional dependency also exists in this relation, that what? Location is dependent on store ID. Okay, so this particular relation is not in second normal form. Is it in first normal form? That we need to check first, that whether it is in first normal form. We see there is each and every row and column is independent. Okay, there is no repeating rows, there is all attributes are atomic in nature. Okay, so we can say that this relation is first normal form. But while checking this, functional dependency said that the primary key for this relation having customer ID and store ID. Okay, and it must determine the location, but we can see that is the prime attribute. Okay, determines the non-prime attributes. The subset of a candidate key determining what was our second condition? No prime attribute is dependent on the proper subset of any candidate key. And here we see that the proper subset is what? The store ID is proper subset of candidate key, and the non-prime attribute location is dependent on the store ID. So this particular condition met here. So we can say that this is not in second normal form. So what is the solution? We need to break up the relation and make the additional table that is shown here. So we have created additional relation table purchase and table store. Okay, breaking the given relation into customer ID and location, customer ID and store ID and store ID and location. We can check here customer ID and store ID and location. Okay, so customer ID 1 visits store ID this, customer ID 1 store ID this, customer ID 2 visits store ID 1. Similarly, customer ID 3 visits store ID 2. Okay, and for each store ID we can have a fixed location. We can say store ID 1 is located at Patna, store ID 2 is located at Delhi, store ID 3 is located at Noida. Okay, so it's eliminating this condition that not any non-prime attribute is dependent on subset of candidate key. Okay, so now here we can say that store ID is the purchase, in purchase relation a customer ID visiting store ID. So we can say in this, okay, this is okay key attribute, we can say it's candidate key. Similarly, in this is the candidate key. Okay, so now it is normalized, and normalized in which state, this is it 2NF. Now, what is the third normal form? So, a table designed is said to be in third normal form if it follow the conditions like it must be in 2NF. For example, when we are discussing the second normal form, the first condition was it must be in first normal form. Similarly, for the third normal form, it must be in 2NF. Okay, so it needs to be 2NF. Okay, first condition. Then secondly, there should not be any transitive functional dependency. Okay, transitive functional dependency of non-prime attribute on any super key. If there is any, then we need to remove it and then it will be in third normal form. So these two condition needs to met while for verifying any relation to be in 3NF. Okay. So what is a prime attribute? What is a non-prime attribute? We have earlier said that the non-prime attribute is what that is not part of candidate key. We have earlier discussed in a example, if there are three attributes A, B, C, and if A and B is our candidate key, then A and B are prime attribute and C is non-prime attribute. Okay. So we can explain the 3NF that a table is 3NF if it is in 2NF for each functional dependency x to y, at least one of the following condition holds. And these two condition, okay, given here, that at least one needs to be verified. Either x is the super key, that means if there is functional dependency for any given relation, if there are functional dependency x to y, then it needs to verify that this x is either super key or y is a prime attribute. Okay, y is a prime attribute. Either, for example, if there is x to y, okay, so either this is what super key or y is prime attribute, means it is part of candidate key. For example, if there is given xy, okay, for any given attribute set xy, okay, if the given functional dependency x driving y, okay, so with either it is candidate key, okay, super key, or this is prime. So what will be if in case it is the candidate key, then for this functional dependency it will be in third normal form. But if x is the only, okay, candidate key and x is determining y, then also this is in third normal form. Okay, because x is super key. Okay, so taking an example here, the given relation book details having fields book ID, genre type and price. Okay, here we see that genre ID and genre ID determines genre type. Okay, genre ID determines genre type. Okay, so here what is the condition? The condition is there should not be any transitive functional. What is transitive functional dependency? Let us discuss it first, then we will forward. Okay, go forward. Then if there is a functional dependency holds x to y, okay, and y to z, then we can say that x will determine z. This is transitive functional dependency. Okay, so here we see that book ID determines genre ID. You know what is the book ID? Book ID F, then genre ID is 1. Book ID 2, then genre ID is 2. Book ID 3, then genre ID is 1. Book ID 4, then genre ID is 3. Book ID 5, then genre ID is 2. Okay, so here we can say that book ID determines genre id. Okay, also genre id determines genre type. Okay, if we say this is x determining y and y determining z, then also we can say book id will determine genre type. Okay, so that means here exists transitive functional dependency. Okay, so we need to eliminate for normalizing this relation into third normal form. So for this normalization, we break this relation into book table and genre table. Okay, now in this tables, in the both the relation, we have eliminated what? We have eliminated this condition, this condition. Okay, now in the first relation, book id determines genre id. Okay, and in relation to genre id determines genre type. So there is no transitive functional dependency. Okay, now what is the BCNF? Yeah, Boyce Codd normal form. So the first condition, it should be in third normal form. Okay, so it should be in third normal form. Then what additional in this type of normalization? Why it is termed as 3.5 normal form? Okay, so in previous, in the third normal form, we having two condition, and one of these two condition needs to met for verifying any relation to be in third normal form. Okay, now we are restricted on this condition only. That means it should be there for any given relation to be in 3.5 NF or in Boyce Codd normal form. One and only one condition that needs to be verified. In this case, for third normal form, whether it is not there, but if it is to be true, then we can say this is in third normal form. But now it is the essential condition, one and only essential condition that needs to verify that for any functional dependency x to y, x should be the super key. Okay, so coming on the BCNF. Okay, so it is stricter than 3NF, and stricter on what point? On the point if a functional dependency x to y, x should be the super key of the table. Okay, that was the first condition, and here we restrict it on this condition that it should be there. Okay, otherwise it will not be in BCNF form. Okay, for example, here in this relation having the attributes student, course and teacher. Okay, we having the key student and course. Okay, this is the primary key. Okay, and the functional dependency is here shown that student and course determines the teacher. Okay, and teacher determines the course. Okay, so here we see that teacher is determining, okay, determining what? Course. Okay, but teacher is not what? Super key. What is the super key? Student and course. Okay, but here is a functional dependency, teacher determining course, and teacher means what? X to y. Okay, what is the condition? That x should be the super key. In the first functional dependency, this is super key. So this function, if there exists only one functional dependency, if there was only this functional dependency, then we can say that it was in Boyce Codd normal form. But there also exists this functional dependency, and this is what? Teacher determining course, but teacher is not the super key. So this is not in 3.5 normal form. So we need to break this relation into two tables as student, course and course teacher. Okay, after breaking this relation, we find out that this condition, and why we break this condition? Because we need to break on this. Okay, teacher, course. Okay, so if on this functional dependency, teacher determining course, So having these fields on our relation, that is teacher and what, course. Okay, and except this we have only student and course. Okay, so student, course, this will maintain this. Okay, and this will maintain this, then this particular functional dependency. So this will be student and course with all the values that verifies it, with the functional dependency this. So if for this relation, the functional dependency that will hold, that student comma course. Okay, it will determine the course student. Okay, student will determine course. Okay, here student and course. Okay, so student and course, this will be the key attribute. Okay, for this. And here the teacher, here the teacher will determine the course. Okay, now for the fourth normal form. Okay, for the fourth normal form, what is the condition? There should not be any multi-valued dependency. Okay, multi-valued dependency for each unique value of x. Okay, there is more than one y. We can say if such type of records exist where for unique value of x there is more than one y, then there exists multi-valued dependency. Okay, so the first condition, it should be in BCNF. Okay, then we will verify there should not be any multi-valued dependency. Okay, so taking an example, in this relation with fields student, what is the major subject and what is the hobby. Okay, so this is the key attribute, this is the super key, student, major, hobby. Okay, we will see that for each student, for example, here is Aman, okay, whose major is management, having two hobbies. Okay, similarly we can see that here is Raj, okay, who plays football but taken two major as management as well as medical. Okay, so if such scenario exists, then we can say this is not in fourth normal form, although it is in 3.5 normal form. So what we need to do, we break this into two relations with student and major and student and hobby. Now we eliminated this multi-valued functional dependency by breaking up the relation into two relation. Now what is the fifth normal form? If for any given relation, if the relation is in its ultimate, or we can say that further we cannot break the relation, then it is in fifth normal form. So we can say we can decompose and we can verifying it that there is no joint dependency. Okay, so we can decompose table further to eliminate redundancy anomalies when rejoining the decompose. That means ki we cannot break further, we cannot break the relation further to eliminate any redundancy or thing, so that we can say it is in its ultimate or its maximum broken form of relations. Okay, so if in case if we further break, then we will lose some data. Okay, so we can simple words that there should not be any joint dependency. Okay, for example, here there is a relation seller, company, product, having the primary field as seller, company and product. Okay, and here we see that there exists multi-valued functional dependency on company and product. Okay, and the product is related to company. Okay, so we will what, break it into two relation. Okay, and we will verify the condition that if further we join this on the common attribute, then it will not result in loss of any data. Okay,